y is equal to the sine inverse of x. We have to find dy on dx. We take solution. Y equal to the sine inverse of x will simply imply that sine y will be equal to, if we take the sine of the sine inverse of x, it gives us x. Then differentiating both sides with respect to x, this will give us the derivative of sine y gives us cos y dy on dx is equal to, we have to differentiate x with respect to x, which gives us 1. We are finding dy on dx, so we are going to divide both sides by cos y. Then dy on dx will be equal to 1 all over cos y. We need to express dy on dx in terms of x. That means we need to find cos y in terms of x. We are going to make use of this. Sine y is equal to x. We can express x as x over 1, which is, we know that the sine of an angle is given by, the sine of an acute angle is given by the opposite all over the hypotenuse. We are going to represent this on a right angle triangle. Representing sine y equal to x on a right angle triangle, let's take this acute angle to be the angle y. The sine of an angle is given by the opposite over the hypotenuse. The opposite is x. This is the opposite of the angle y. Here we have x. The hypotenuse is 1. This adjacent side, we don't know it. We are going to make use of Pythagoras theorem to find the adjacent. So we can let this side to be t. By making use of Pythagoras theorem, we can find t by using Pythagoras theorem, the square of the hypotenuse is equal to the square of the base plus the square of the height. This will give us 1 square to be equal to t squared plus x squared. We are looking for t. 1 squared remains 1. We are going to transfer x squared to the left, which becomes negative x squared is equal to t squared. Then our t will simply be the square root of 1 minus x squared. We are going to replace t here with the square root of 1 minus x squared. Knowing t, we can write down the cos of the angle y. Cos y is given by the adjacent all over the hypotenuse, which is simply equal to the adjacent of the angle y is the square root of 1 minus x squared all over the hypotenuse, which is 1. This will simply be equal to the square root of 1 minus x squared. Knowing cos y, dy on dx will simply be equal to 1 all over the square root of 1 minus x squared. This will give us dy over dx to be equal to 1 all over the square root of 1 minus x squared. Then we conclude, therefore, comma, for y equal to the sine inverse of x, then dy on the x will be equal to 1 all over the square root of 1 minus x squared. This is how we get the derivative of the inverse trigonometric function sine inverse of x. If in case you have any worries in what we have just done, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.